Assalamualaikum warahmatullahi wabarakatuh. This part of video is focusing about elementary row operation, or we call that ERO. So let's start our video with my simple explanation about this node. Elementary row operation are fundamental manipulation performed on the rows of the matrix. There are three types. First, row swap, interchange two rows. Second, scalar multiplication, multiply a row by a non-zero scalar. And last type is row addition, add a multiple of one row to another. They preserve the solution to system of equation and are reversible. The goal is often to reach the triangular or diagonal matrix, adding in computation and revealing system structure. Okay, that's all from me about introduce part. Let's proceed to the simple example for this topic. So, this example question let's use ERO. So, the question is given A, matrix A is 1, 2, 3, 2, negative 3, 2, 3, 1, negative 1. So, first we write this matrix A, okay, and then first, we must, the question one is we want to uh, change the matrix A become an echelon matrix. So, the echelon matrix, we must, the form of the echelon matrix is 1 and the over the 1 is must 0 and the next is 1 and below of the 1 is 0. So, wait a minute. I write again. It's 1, 2, 3, 2, 3, 2, 3, 1, negative 1. So, the step is we must change 2 become a 0. So, what must we do? So, uh, if we want change the 2 become a 0, we must, uh, the row 1, we must multiply row 1 with negative 2 plus row 2. And we want a 3 become a 0. So we multiply row 1 with negative 3 plus R3. So we get a 1, 2, 3. We get 0, negative 7, negative 4, 0, negative 5, and negative 10. So next, we want this row 2, we want negative 7 become a 1. So we must multiply negative 1 over 7 with R2, and we want to negative 5 become a 1. So we multiply 1 over 5 with R3. So we get 1, 2, 3, 0, 1, 4 over 7, 0, 1, 2. So next, we want this row 3. In this row 3, we want 1 become a 0. So we write the equation is negative R2 plus R3. So we get 1, 2, 3, 0, 1, 4 over 7, 0, 0, 10 over 7. Okay. So The last step is we want this 10 over 7 become 1. So we must multiply 7 over 10 with R3. We get the answer. The answer for the question 1 is actual matrix 0, 1, 4 over 7, 0, 0, 1. Okay, so for the uh, question 2, we want a reduced actual matrix. So after we get this answer, we write it again. 1, 2, 3, 0, 1, 4 over 7, 0, 0, 1. Okay, so we want these two in row 1, we must 2 become a 0. Okay, so we must multiply negative 2 with R2 plus R1. Okay, so we get 1, 0, 30 over 7, 0, 1, 4 over 7, 0, 0, 1. Okay, so after that we want this in the row 1, we want 30 over 7 become 0, and in the row 2, we want 4 over 7 become a 0. So the step is we must multiply 4 over 7 with R3 plus R2, and negative 3 over 7 multiply with R3 and R1. So we get the answer for the question B is, the question 2 is 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. So that's all to the question, and we go to the next example. So
So my name is Muhammad Fajarul Rizafin. So today I'm going to teach you guys how to solve matrices by using arrow method, which is elementary row operation. So if we have matrices 3 by 3, which is 1, 3, 3 for the first row, and second row 1, 4, 3, and last row 1, 3, 4. So first of all, we need to check the first row, first column must be 1. After that, if the first row and first column is 1, we go to the next row, which is second row, first column. If it not 0, so we need to subtract it or do something to make it turn to 0. So what we're gonna do is arrow here, and then if the first row is okay, so we just write it down, copy that, and then second row. So what we're gonna do is we subtract the second row with first row. Got it? We just write B2, 2 is row, minus B1. Okay, so first column we have first row we just copy, second row we have 0, 1, 0. So we check the third row also. If not start with a 0, we make until it to 0. So what we can is we use B3 minus B1. So it became 0, 0, 1. So after we get this, we must go to the first row After 1, we must have 0. So here we have 3. So we need to find a way to turn it into 0. So how? By B1 minus 3 B2. So it will be 0 3, and the other we just copy that down because we already get. And then after the second column and first row we get 0, and then we go through to the third column and first row. If it not 0, we must do something until it turn to 0. So we just write it just for the first row, so the others will we copy. So how to make the 3 become 0? So we choose first row, so we minus it with 3 by 3, so it will be 1 0 0. So this is how we do the arrow method, which is elementary row method.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, we are at 7.3 using 7.3 inverse metric using ERO. Okay, let's compute the inverse of non-singular metric using elementary row operation. Okay, here we go. The inverse show to find the A inverse. It's mean A inverse is equal to determinant A will not be 0. Okay, the first thing first you must know is the formula. A palang I will be I palang A inverse, or maybe it can be B or C like I show in this paper, on this paper. Okay, let's proceed to my question, my simple question, 2 by 2. Find inverse of B by using ERO, 2 by 2. Okay, um, we must expect at the, okay, I'm sorry, the first solution, we must make a column like this. Column B, palang I. I means identity matrix. We must expecting at the final answer, and the identity matrix will be shift to the left, like on the last solution I have made. Okay. The second solution is solve the first column. Okay, here the simple one, we make um we must make the first column to be 0. This is a diagonal line. Diagonal line must be 1. Diagonal line must be 1. The other part will be 0. Okay, here we make it 3 R2 minus 2 R1. The 3 R2 multiply with 2, subtract 2, multiply with 3 on the row 1 will become 0 on the row 2. Here, 0. Okay. The the next part, the next solution we must do is we solve the row 1. We make it 0. Okay, 1 over 3 multiply with R1. Okay, here you can see R1 is 3. and multiply with 1 over 3 become 1. And on the row 2, 1 over 12 multiply with row 2, negative 12 become 1. So here you can see on the diagonal become 1 as as I said just now. Okay. On the last, we must say that we must show that B inverse equal to 1 over 3, 0, 1 over 6, negative 1 over 4. Okay, that's all for me. Let's proceed to the next example question, lie. Thank you. Okay.
Hello everyone, my name is Lai Wenqing. Today I would like to talk about how to find the inverse matrix of A by using ERO, which is elementary row operation. First of all, we should write the matrix A in a form of argumented matrix, which in form AI, and finally and change it into IB form, where the B is the inverse matrix of A. After that, we should obtain a leading one in the first position on the leading diagonal. Hence, we exchange the row 1 with row 2 in order to get the leading one. After that, we should obtain the zeros under the leading one in the first column. So we multiply the negative 4 with row 1 and plus together with row 2 in order to get the 0 in the row 2. Then we multiply the negative 4 with row 1 and plus together with row 3 in order to get the 0 in the row 3. Moreover, we should obtain a 1 in the second position on the leading diagonal. So we multiply the negative 1 over 6 with row 2. Furthermore, we should obtain the zeros in the column 2. So we multiply the negative 2 with row 2 and plus together with row 1 and get a 0 in the row 1 and multiply the 4 with row 2 and plus together with row 3 in order to get the 0 in the row 3. Okay, then in order to get the 1 in the third position on the leading diagonal, we multiply the negative 1 over 6 with row 3. Lastly, we should obtain the zeros in the third column. So we multiply the negative with the row 3 and plus together with row 2 to get the 0 in the row 2 and multiply the negative with row 3 and plus together with row 1 in order to get the 0 in the row 1. And finally, the inverse of the matrix A can be obtained. Thank you.